when we're dealing with pressures, we can write a Kp expression. A Kp expression is written the same way as an equilibrium expression with concentration, except we're going to have P's instead of brackets and parentheses. So it's the pressure of C raised to the power of C times the pressure of D raised to the power of D over the pressure of A raised to the power of A times pressure of B raised to the power of B. So in this problem, first thing we need to do is write our equilibrium expression. So the pressure of NaCl then, reading the problem, it says that the pressures at equilibrium were found to be the following. Notice it doesn't say anything about initials, so we can just plug these values directly in. Paying attention to which substance goes where. Also, making sure that we remember to add our exponents where needed. Make sure that you can plug that in the calculator. It should be 1.2 squared divided by 5 times 10 to the negative second squared divided by 3 times 10 to the negative 1. And in 2 sig figs, you should get 96. Because our K is greater than 1, the products are favored. Go ahead and pause the video and try this one on your own. Restart when you have an answer. First, we write our equilibrium expression. Then they gave us Kp. And they gave us the pressure of N2O4, which goes on the bottom. We don't know the top, but we do know it's squared. So multiplying by 2.71 and then square rooting, we want 3 sig figs. So we get 0.600 ATM. Looking back at our KP is less than 1, so the reactants are favored. I'm going to pause the video, try this one on your own, restart when you have your answer. First thing we needed to do was write our Kp expression. And on this problem, it says that we start with 0.862, calculate equilibrium. So we need a Rice table. So we have 0.862 and 0.737. They didn't say anything about NH3. We know our nitrogen should go down by some amount. Hydrogen should go down 3 times some amount, again because of that coefficient. And NH3 should go up by some amount. Now that we have our equilibrium line, we can plug that into our equilibrium expression. So our NH3 was 2x. And because our K is so small, we can ignore the minus x's. So our 4.31 times 10 to the negative 4th times 0.373 times 0.862 gives us and then 2x squared gives us 4x squared. Since we ignored the minus x, we do need to calculate our percent dissociation. So x over our initial. Going to do your smaller initial. It's 1.58%, so that's definitely less than 5%. So now we can just plug in our answers. So our x was 0.0059. So 0.862 minus x is 0.862. For our hydrogen, and our NH3 should be 2 times our x. Finally, our Kp was 4.31 times 10 to the negative 4th, so the reactants were favored.